Hey everyone, today we are going to talk about the different forms that numbers can take. So we know that every number, as we've talked about, has two things. It has value and it has sign. But numbers can also be written in various forms that are all equivalent to each other. So what that means is that a number can be taken from one form but look different and still have the same value and sign. So we call those equivalent forms. So let's look at some equivalent forms of some nice numbers. So 4. The number 4 right now, it's written is probably in its best form, but we know that its value is 4 units from 0, and we know that its sign is positive. But I could write 4, if I wanted to, as a decimal. I could write it as 4.0. Did I change the value or sign of that number? No, but I did change what it looked like. I mean, another equivalent form, we know that we could do 4.000 also would be equivalent or worth 4, right? We're not adding anything on with those decimal places. So those are some decimal forms that are both equivalent to 4. I could also write 4 as a fraction and it would still be equal. If I wrote 4 of a fraction, I would write 4 over 1. That's still worth 4, it's still positive. And I could keep going, I could write these fractions forever. I could write, instead of writing 4 over 1, that has value 4, I could write 8 over 2, that's worth 4, or 12 over 3. And I could do this for the rest of my life. So 4 has a bunch of different forms, how it looks, but they're equivalent because they keep the same value and the same sign. They're still positive, they're still 4. That's also true for negative numbers. So negative 3 could be written in decimal form as negative 3.0. We'd keep that negative sign with it because we have to keep the sign the same to be equivalent. Or we could write negative 3 as a fraction. We could write it as negative 3 over 1. That can also look like this. Those are all equivalent. We could write it as negative 6 over 2. It would still be negative. It would still have that equivalent form. That same value, equivalent value. So just the same thing in a different form. 0 also has other forms. We could put it in its decimal form. 0.0000. I could go on forever with those zeros and it would still be equivalent to 0. I can also write 0 as a fraction. 0 over 1. That's equivalent to 0. That's worth 0. We could also write it 0 over 2. That's worth 0. 0 over 100. That's worth 0. So all numbers have multiple forms, because they all have the same value as the nicest version, but they just look different. This is also true when we're talking about numbers and values that aren't super nice. So we did a lot of work on putting fractions onto the number line. Fractions are numbers whose value isn't super easy to deal with because it's not a whole number away from 0. But we can still take fractions and put them into different forms. So every single fraction has an equivalent decimal form. And there's a decimal that is worth the same and is exactly the same value and sign as every single fraction out there. So today we're going to work on how do we figure out what decimal goes with this fraction. What decimal has the same value as this fraction? Value and sign. Some of them we might know. So you might already know a half in your head. And maybe you even know a quarter. But I doubt you know negative 3/8 and 2 3/5. So we are going to work through the process of how we would find the decimal version of each of these fractions. So here we go. Let's think about this fraction, a half. We talked about how a half is as if we had a whole cut into 2 pieces. right? We have one whole cut into two pieces. Another way that we can say cut into two or fold into two equal pieces is divide, right? When we divide things into equal parts, that's what we're doing. So really what we're doing is we're taking one thing and we're dividing it into two pieces. So a half is really a division problem. And every fraction is a division problem. Secretly. It's always the top divided by the bottom number. So we're going to do a little bit of long division here, set this up. So when we set up our long division, the thing that's getting divided is on the inside. So in this case, what's getting divided is 1. And it's getting divided into two parts. So I put that number out here. And I need to divide, and that will give me my decimal form of my number. So let's review long division. So I check, okay, 2 goes into 1 how many times? Oops, 2 doesn't go into 1, goes in 0 times. But I don't get to stop. What I do instead is I put a decimal, because I know that this number is going to go into the decimals. I put the number in the decimal right after my 1, and then I pop it up into my answer 2. Okay, and then I ask myself, 2 goes into now, okay, 2 goes into 10 how many times? Oh, 2 goes into 10 5 times. And then 2 times 5 is 10, and it divides evenly. So that means that 0.5 is my decimal form of a half. 1/2 and 0.5 are equivalent to each other. They have the same value, they're worth the exact same amount, and they have the same sign. They're both positive, so these are equivalent fractions. They have the same value. They are the same number. They just look different. Let's work through a few more. So a fourth. Fourth is going to be pretty similar. We talked about how a fourth is one thing divided into 4 pieces, and a fourth is one of them. So when I think about this fraction of a fourth, I'm really thinking of the division problem, one thing divided into 4 pieces. So we'll set up that division problem. Like I said, the thing getting divided is what lives in the house, and then the other number goes on the outside. So 1 is what's getting broken up into 4 pieces. I ask myself, 4 goes into 1 0 times, so I put my 0 above, and then I know I'm going to have to go into my decimals. I add a 0, and I ask myself again. Now, 4 goes into 10 how many times? Okay, I know that one. 4 goes into 10 twice. Write that number above, and I do the fact. 4 times 2 is 8, and I subtract it, and 10 minus 8 is 2. I didn't get a 0, so I have to bring another digit down because I'm hoping to end this division. 4 goes into 25 times. 4 times 5 is 20. And I subtract it off and I get that happy 0 because I'm done my division problem. So this means that 1/4 is exactly the same in value and sign. It's the same number as 0.25. We might think, because they look different, that they're different, but they're not. Same exact value, they have the same exact worth. We can think of them interchangeably. They're just in the 2 forms this number can take. What happens when things get negative? So even negative fractions and all negative numbers have an equivalent decimal form. It's just that when we write that decimal, this will also be negative. So I like to kind of think about that ahead of time and keep that negative sign off to my side. So sometimes I like to highlight that negative sign so I don't forget about it. That can be one thing you do. Or you can kind of set up your final answer at the beginning so you don't have to keep it in mind. So this number, I know at the end, it has to be exactly the same. It's gonna be negative. It's gonna be negative some decimal. Let's figure out what that decimal is. I set up my division problem. So 3/8 is the same thing as 3 divided by 8. And I set up my little division. The 3 goes inside because it's what's getting divided. And the 8 is on the outside. I long divide. I ask myself, 8 goes into 3 0 times. So I add a decimal above and below, and I give myself another place. Now 8 goes into 30 3 times, because 8 times 3 is 24. And I'll subtract that off. And 30 minus 24 is 6. Okay, I need to bring down the next place. 8 goes into 60. 8 goes into 67 times, because 8 times 7 is 56. I subtract that off. 60 minus 56 is 4. And I bring down another 0. Oh, long division can get tedious. Okay, I ask myself, how many times does 8 go into 40? 8 goes into 45 times. Awesome. Because 8 times 5 is exactly 40. I subtract it off. Happy 0. I'm done dividing. I figured out my value. So it looks like, when I divided 3 by 8, I got this result, that 3/8 is the same as 0.375. As a decimal, those things are equivalent. So negative 3/8 is going to be the same exact number as negative 0.375. They're just in different forms. One more, mixed numbers. When we're dealing with mixed numbers, I know that I have 2 wholes, and then this fraction here is representing the part that's left. So there, I have 2 wholes, and then I have 3/5 more. When I'm dealing with decimals, it's kind of the same. If you have a number in front of a decimal, so say our number was, side note, 5.6, kind of works the same way. The number in front is the whole, so I have 5 wholes, and then I have 0.6 more. That's the part of the whole I have left. So I can kind of forget about these wholes here, because if I have 2 3/5, I'm still going to have those 2 wholes when I turn it into a decimal. It's not going to change that it's still 2 whole things. We have the same value. So when I go to figure out what the decimal part is, I'm not going to worry about the wholes. I know I'm going to keep them, and I'm just going to think about how to turn the part into a decimal. So I take my fraction. My part is 3/5. So that means I need to do 3 divided by 5 to get my decimal part. The 3 goes inside because it's getting divided. The 5 goes outside. I walk myself through. Okay, 5 goes into 3. Never. So I add a 0 and some decimal points and my next place. 5 goes into 30. Oh, so nice. It goes in exactly 6 times because 5 times 6 is 30. I'll subtract it off. Be happy that 30 minus 30 is 0. Happy 0, I'm done dividing. So that part, 3/5, is the same thing as 0.6 or 6/10. So I need to add that extra 0.6 onto my 2. So 2 3/5 will be 2 6/10. These guys are equivalent and in 2 different forms. So, a big takeaway here. Fractions represent a part of a whole. so do decimals. They're both representing part of a whole. We can turn fractions into decimals using division because the fraction symbol is actually a hidden division symbol. What do I mean by that? Think of the division symbol as a fraction, but the two numbers are just dots. I think that's where the division symbol even came from. So takeaway, you can write fractions as decimals. They'll be equivalent numbers. They'll be the same number, a different form. And the key, the process to do it is by dividing the top by the bottom, the numerator by the denominator. All right, I'll see you next time for part 2.